In today's lesson, we're going to talk about what it means to multiply when we have exponents in the expression. So you can see here I have several expressions laid out. They're ranging from a little bit easier to a little bit harder, and we're going to walk through the steps of multiplying with exponents. Okay, so here is the actual rule. Okay, when you've got exponents like this, let's say we've got x to the third times x squared. If I expand this out, which means I take x to the third and I actually write out the fact that that is 3 x's, and I expand out x squared and show that it is 2 x's, I can see that altogether I am multiplying x 5 times. So x times itself 5 times, which means I can then simplify that to say x to the 5th power. Okay, so I can expand it out and then combine them all, or I can understand that if I expand them out, I'm going to end up adding the 2 exponents together for the final exponent. Because if I write out 3 x's and then 2 x's, that's going to be 5 x's total. Now don't confuse that with 5x. I'm not going to actually write it, okay? X to the 5th is different from 5x. Yes, there are 5 x's here, but 5x would be if it was x plus x plus x plus x plus x. That would be 5 x's added together. Because I'm multiplying, we call this x to the 5th. Okay, so same thing over here. B to the 4th times b to the 3rd. You'll notice there's no multiplication dot here. And that's because in multiplication, you actually don't need to have a multiplication dot. Okay, as long as you can tell that these are 2 different parts of the expression, you don't need to put anything in between. They can be squished together. So here I have b to the 4th power times b to the 3rd power. And again, if I expand that out, there's b to the 4th power, and there's b to the 3rd power. Altogether, I'm going to multiply b 7 times to get b to the 7th power. And you can see if I just added the 4 and the 3, I could have skipped actually writing it all out and just wrote b to the 7th power. Sometimes you'll see multiplication shown like this with parentheses. Okay, so this is a to the 5th times a to the 3rd. So instead of writing it out this time, I know that I'm going to write out a 5 times and then a again 3 times. That's going to be a total of 8 times. So a to the 8th power. Over here I have c to the 6th power times c. Okay, anytime you see an exponent that does not, anytime you see a base that does not have an exponent, you know the exponent is automatically 1. And the reason is because how many c's do you see there? You see 1. So it's c to the 1st power. It's just c 1 time. So if I have c to the 6th times c to the 1st power, that would be like writing out 6 c's and then another 1 c and multiplying them all together. That would be c times itself 7 times. I can even do this with negative exponents, by the way. I'm just going to add a positive 7 and a negative 3. That's going to give me x to the 4th power. We're going to talk about more what negative exponents mean in a later video, but for now you just need to know that the same rule applies. 7 plus negative 3 makes 4. So if I wrote out x 7 times, and then, this is where it gets confusing, x to the negative 3 7 times, what those negative 3's do is they actually cancel out some of the positive 3's, and that's how we end up with the 4 in the end. But again, that's for a later video. Same thing applies if we have 2 negative exponents, okay? If the rule is that when you multiply and the bases are the same, that we add exponents together, this one's going to end up being y to the power of negative 10. Okay, just adding these together. Our basic rule here, and you might see this written out in a textbook later on, is whatever your base is, if you multiply by the same base, so see how a is the same, you take the 2 exponents and you add them together. Okay, that's the generic formula for multiplying with exponents. And like I said, this applies even if they are negative exponents. Okay, over here, we're mixing it up a little bit here. I've got some whole numbers out front. Okay, we've got 2 times 7 and x to the 5th times x to the 3rd. Okay, so because we're multiplying here, okay, multiplying can be done out of order. That's a rule in algebra. Okay, as long as there's no adding and subtracting going on, I can multiply in whatever order I feel like it. So I'm going to take the 2 coefficients, the 2 and the 7, and multiply those first. So 2 times 7 gives me 14. Okay, I haven't done anything wrong. I just multiplied those two first. And now I'm going to take the x to the 5th times the x to the 3rd. And I know if I write all those x's out, it's going to show me x to the 8th. Okay, so this all multiplies just to become 14x to the 8th. Okay, this is called simplifying. We've done simplifying before in the past. And again, we're making simpler expressions here. Okay, multiplying like this. Same idea here. I've got a 5 that can multiply with a 3. That becomes 15. And then b to the 4th and b to the 8th. If I wrote out 4 b's and then 8 more b's and showed they all got multiplied together, that would be b times itself 12 times. We can even do this with more than just 2 pieces here. We can do this with 3 expressions or 4 or 5. I mean, it's unlimited. Again, you can just go out of order. Do the 6 times the 2 times the 3. 6 times 2 is 12. 12 times 3 is 36. X squared times x to the 3rd times x to the 8th. So these two will be x to the 5th power. And then 8 more x's multiplied after that, x to the 5th, 8 more x's would make x to the 13th power total. 3 times 8 is 24. X to the 7th multiplied to x to the negative 2 power. Again, our rule is that we add the exponents if they have the same base. So 7 and negative 2 would be positive 5. And then here, a negative 5. So this time we have a negative coefficient, and that's okay. It's not the same as the exponent. This is the coefficient outside of the variables. The negative 5 times the positive 2. Just be careful not to mess up your negatives there. A negative times a positive is negative 10. A to the 3rd times a to the 4th is a to the 7th. And you can see here I've got another variable, okay? Not just a, but now I've got b also. So the a's combine. 3 a's multiplied by 4 more a's makes a to the 7th. And then here's b to the 5th. So b 5 times, and then another 6 times. That's b to the 11th total. Okay, so see how this whole expression is simplified to this little guy right here. It's so nice. And then lastly here we have 4 times 6. We can do our coefficients first. X to the 7th times x squared. That would be x to the 9th. And then y to the 3rd times y. And again, if there's no exponent, we know that it's automatically 1. You can draw in the 1 if you'd like. Y to the 3rd times 1 more y would be y to the 4th. Okay? Now, I want to make sure you guys do understand that you can only combine when the bases are the same. So for instance, I'm going to put a little practice problem right here and show you what you can't do. So let's say I had b squared times c to the 5th. I can't do anything with that. This, if I expand it out, is b times c, 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 c. It's still just going to simplify back down to b squared times c to the 5th. So this rule only works when you have the same bases here, okay? And again, you could have different variables in the problem. You just keep the same variables together. So x to the 7th and x squared became x to the 9th, but they were separate from y to the 3rd and y to the 1st. Okay. Now, let's go ahead and practice. So I am going to do a little bit more pausing in between each problem here so that you have time to work it out on your own and then check yourself. Okay, a to the 7th times a to the 8th, that's going to become a to the 15th power. X to the 5th times x to the negative 7th will become x to the negative 2 power. And again, we're going to talk more about what a negative exponent means in a later video. C to the 4th times c to the 6th, so there's 4 c's multiplied, then 6 more. That's a total of c 10 times, so c to the 10th power. X to the 3rd is going to join up with x squared. So x to the 3rd, x 3 times, x 2 times, that's x 5 times, x to the 5th power. y to the fourth times y to the second power is y to the sixth power. It's going to get multiplied 6 times. Okay, over here we have some coefficients going on. The 2 times the 5 gets multiplied first. X to the third times x to the 8th would be a total of x to the 11th. Five times -3 makes -15. B to the 5th times b to the 4th. So 5 b's being multiplied, 4 b's being multiplied for a total of 9 b's being multiplied. So -15 times b to the 9th. You'll notice in this one that there is no coefficient here. And when that happens, there's always a 1 hanging out. So you could think of it as 6 times 1, or you could just think of it as, well, just 6 is the coefficient hanging out there. Either way, you're going to get 6 anyway. X to the second power times x to the fourth power. 2 x's times another 4 x's makes x to the sixth power. Y times y to the second power makes y to the third power. Now 8 is very similar to number 7. There's no coefficient over here. So again, you can draw in the number 1 if you would like. So -2 times 1 is -2. A to the third times a to the 5th would be a to the 8th. And b to the 6th times b to the 4th is b to the 10th. So that's what it looks like when we are multiplying with exponents. And there is another part of this lesson when we're multiplying, okay? It's called raising a power to a power. Okay, now a power in algebra means an exponent. Okay, so we're basically saying we're raising an exponent to another exponent. So I want you to kind of see the difference here. This would be multiplying with exponents. You've got a base with an exponent times a base with an exponent. Okay, a base with an exponent times another base with an exponent. And what's going on here is you have one base with an exponent, and this whole thing is getting raised to another exponent. In other words, it's being raised a power to a power. Okay, so what x to the 5th squared, or to the second power, looks like is I would take x to the 5th times x to the 5th, because it's this twice. So x to the 5th times x to the 5th. If I expand that out, that is 1, 2, 3, 4, 5 x's for the first one, x to the 5th, times another 5 x's, 1, 2, 3, 4, 5. How many x's total are getting multiplied like that? We've got 5 here and 5 here. You're right, x to the 10th power. What do you guess the rule is here? X to the 5th raised to the second power became x to the 10th power. What rule do you think we could be using here that we could use in another one? Okay, so maybe you're thinking it has to do with the exponents, because 5 times 2 ends up being 10. So let's try that out. B to the third raised to the 5th power. That means I'm taking b to the third 5 times. Okay, b to the third, b to the third, b to the third, b to the third, b to the third. If I expand all these out, I'm gonna have 3 b's, another 3 b's, another 3, another 3, another 3. How many is that? 3, 5 times, right? Which would end up being b to the 15th power. 3 times 5 is 15. So if that was your guess, you are correct. I can just take the exponents and multiply them instead of having to expand everything out. I can do it with negative numbers too, by the way. I'm going to skip this one and come back to it. Let's go y to the 4th to the 3rd power. That's just going to be y to the 12th power. And again, if you don't remember that rule, you can expand it out. Y to the 4th times y to the 4th times y to the 4th. That's y to the 4th 3 times. So you've got 4 here, 4 here, 4 here. That's a total of 12. Now again, I did say you could use negative exponents here. Because the rule is just that you multiply the exponents, it doesn't matter if you've got a negative exponent. Negative 2 times positive 3 is negative 6. Okay. What if there are 2 bases going on in here? And what if there's no exponents in this case? So remember, if there are no exponents, there's always an exponent of 1. Okay. When you've got more than one thing going on in here, this to the third power applies to everything. Okay, so I'll show you a couple of different ways you can write this out. Xy to the third power, you could write that as xy times xy times xy. Okay, so 3 times I wrote down xy. How many x's is that? 1, 2, 3. So that's x to the third power 3 times. And how many y's? There are also 3. So y to the third power. Or I could have looked at it as the 3 got multiplied to the exponent of 1 in both of these. Okay, that one's not as obvious how it worked because the 1 kind of tricks some people up. So let's try this one over here. Okay, x to the third, y to the negative fourth squared, meaning I'm going to take this times itself twice. And the rule is I can multiply the exponents. So x to the third twice, that's going to be 3 x's and then another 3 x's. That's x to the sixth, 3 times 2. Y to the negative fourth twice will be y to the negative fourth and then another y to the negative fourth for a total of y to the power of negative 8. Again, negative 4 times positive 2 gets me negative 8. Okay, we're getting even trickier now. What if we've got coefficients in here? The coefficient also get raised to this power. So 2 to the third power. That's 2 times 2 times 2. Okay? So 2 times a to the fourth times 2 times a to the fourth times 2 times a to the fourth. That's how it looks if I expand it out. 2 times 2 times 2 is 8. A to the fourth times another a to the fourth times another a to the fourth. That's a total of a to the 12th. Okay. Instead of expanding it out, I could have just said, oh, this will be 2 to the third power, which is 8. And then a to the fourth to the third power, which means I multiply the exponents and I get a to the 12th. By the way, when I do 2 to the third power, I am still following the rule because there is still an exponent of 1 there. So I am still doing 1 times 3 and getting 2 to the third power. Most people kind of skip over that idea in their heads though. Okay, so here, 3 c to the 7th to the third power. So 3 to the third power is 27. That's 3 times 3 times 3. C to the 7th to the third power, if I wrote out 7 c's 3 times, that's going to be 21 c's altogether. 2a to the 5th to the second power. 2 to the second power is 4. And then a to the 5th to the second power would be a to the 10th. And lastly, 3 to the second power would be 9. X to the 4th to the second power would be x to the 8th. Y to the second power would be y to the 4th. And again, like before, I'm going to put up some practice problems and go through those ones a little bit slower so you have time to figure them out and then check if you're right. Okay, so a to the 4th to the 8th power. This one would be annoying to have to expand out. So I'm glad I know the rule that I can just multiply the 4 times the 8. So I get a to the 32nd power. Same thing with number 2, c to the 6th to the third power. That'll be 6 c's 3 times. That's c to the 18th power. X to the 7th raised to the second power would be x to the 14th power. Y to the 5th to the third power is y to the 15th power. Okay, so here's where it gets a little trickier. So 2 raised to the second power. So 2 squared is 4. X to the third raised to the second power is x to the sixth. Four to the third power, that's 4 times 4 times 4, 64. X to the fifth raised to the third power, so x to the fifth 3 times is x to the 15th. Eight squared is 64. X to the negative third power raised to the second power. So again, we just multiply. Negative 3 times positive 2 is negative 6. All right, now we're getting a little trickier. So 5 to the third power. That's 5 times 5 times 5 is 125. A to the fourth raised to the third power is a to the 12th. B to the negative second power raised to the third power is b to the negative sixth. Three squared is 9. C to the fifth squared is c to the 10th. And D is all by itself. It's just 1D. So D to the first power, 1 times 2 is just 2. Now it's D to the second power. Two to the fourth power. 2 times 2 times 2 times 2 is 16. X to the second raised to the fourth power. X to the 8th. Y to the second raised to the fourth power is y to the 8th. And z to the third raised to the fourth power would be z to the 12th. Okay, 7 raised to the second power, 7 times 7, that's 49. X to the third raised to the second power is x to the 6th. Y to the fifth raised to the second power is y to the 10th. And lastly, we've got 4 raised to the third power. So 4 times 4 times 4, 64. M to the third power raised to the third power. So there's 3 m's already, and we're going to take those 3 times. So that's going to be m to the 9th. N to the negative 7th raised to the third power. So again, we're just multiplying. Negative 7 times 3 is negative 21. Okay, I'm going to put these two side by side again just so you can really make sure you see the difference here, okay? So when you're just regular multiplying here, you've got 2 bases, okay? X to the third times x squared. So if you expanded them out, which you can do for any of these problems, just expand them out if you get confused on what you're supposed to do, you can see, oh, I'm multiplying x 5 times. Okay, that simplifies to x to the 5th. Same thing here, b to the 4th times b to the 3rd. Oh, that's b 7 times. Whereas here, x to the 5th raised to the second power is taking x to the 5th times another x to the 5th. Okay, so now this looks like one of these problems. You've got 2 bases, so you could expand them out from there. Here's 5x's, here's 5x's, all together that's x to the 10th, okay? The rule here we talked about is if you've got the same base, here are the exponents, you just add the exponents together. The rule over here that you'll often see in an algebra textbook will look like this. If you have, say, a, some number, to the m power, could be any number, and then you raise that to another power, it's always going to end up being a to the power of m times n. Okay, so like negative 3 times 2, 2 times 2, 7 times 3, negative 4 times 2. Whereas over here, if you'll remember, the exponents get added together, okay? This can be very tricky. So I highly recommend, especially at first, that you maybe want to expand out the variables each time so that you can really see what's being asked. And then after a while, it's going to become a little bit more second nature to be able to look here and say, oh, I need to add those exponents together. Or like in this one, oh, I need to multiply those exponents together. All right, there we are, multiplying with exponents and raising a power to a power.